Okay, gang, so this is 4.6, and you have all the skills you need from 4.5. This is just real-life application, so stuff you might actually need one day. And sorry, I'm not here, so make sure you pause the video. I'm going to be talking pretty quickly and writing pretty quickly because I don't have much time to make this video, so bear with me. And like I said, pause it, write it down, and any questions that you have, I will answer next time, okay? But just make the most of today. So, key thing is, we've talked about a lot of this before, but anytime you see something that says doubling, we know that that's going to be 2 to some power. So we talked about this with the penny problem. If something was tripling, then it would be 3 to the something, quadrupling, 4 to the something, and so on. Now, if you start with a certain amount of something, in this case we're talking about bacteria, then you would throw that number out in front. And you actually had a question like this on your homework back in 4.1 and 4.2. But anyway, whenever you start with, that number is going to go out in front. Well, having some technical difficulties there, folks. Sorry about that. I'm trying to fix this real quick. Okay. Been a little while since I made a video, if you can't tell. Okay, so like I said, anytime it says doubling, we're going to see a 2. So you want to write these formulas down. I'm not going to make you memorize them, but you do need to have them handy to use on your next test. And this is the last section before we take a test. So this formula is n sub 0 times 2 to the t over a. Okay, so n sub 0 is your initial amount, and t is your time. A is the amount of time it takes to double. So whatever we're talking about, bacteria population, whatever. Okay, it's very important that these two are the same unit. So days, minutes, minutes, hours, hours, so on. Okay, and so this is just some notation. Anytime you see the sub-zero, that just means initial. If you're in physics, you probably have seen v sub-0 for the initial velocity. All right, so we're going to do 3 things. We're going to find a model, that means just write an equation, for this situation. So I'm going to go through this problem and pick out the important details. For example, it says that it doubles, which tells me that I'm going to use this formula. It doubles every 3 hours. That's the amount of time it takes to double, so that's my A. And initially, there are 1,000 bacteria, so that's my n sub 0. Okay, they didn't tell us how much time has passed, and that's fine because we want our equation to represent, how much population there is after t hours. So the answer to this would be 1,000 times 2 to the t over 3. And I'm just plugging in the information that's in the problem, putting it there. This is the hardest part. Once you get this, everything else is a breeze because all you have to do is plug in. So for part B, how many bacteria are in the colony after 15 hours? So I'm going to plug in 15 for my t. Okay, and I know that 15 over 3 is 5. So in your calculator, you're going to do 2 to the 5th, which is 32 times 1,000. Probably do that in your head and get 32,000. And the last part is the more new stuff that we've been working on, where you're actually solving. So I want to know how much time there has to pass for me to reach 100,000 bacteria. So what I'm going to do is I'm going to take this equation and I'm going to set it equal to 100,000. So 1,000 times 2 to the t over 3 equals 100,000. And this is what we did in 4.5, solving for exponential equations. First thing I'm going to do is isolate. So I'm going to divide both sides by 1,000. And that gives me 100. So then I have 2 to the t over 3 equals 100. And I'm going to have to take the log on both sides in order for this power to come down. So I'm going to take the log, and that's going to give me t over 3 log 2 equals log 100. And you're going to do the rest in your calculator. So all you have to do is take log 100, divide by log 2, and then multiply by 3. And you should get approximately 20 hours. It's like 19 point something, but that's fine if you round. Okay, like I said, I'm working these out quickly, so please pause the video as you need to. What I want you to do is take a second and just try to fill in the information where you can on this one. Just read the problem and try to set something up. So go ahead and pause it. When you're ready, push play. Okay, so I'm going to go ahead and go over this one. So we were talking about rabbit population, and they were introduced onto a small island 8 months ago. So that's how much time has passed. The current population is about 4,100, and it doubles every 3 months. So the first thing is that word doubles lets me know what formula I'm going to use. And that should be an A, but it's okay. So that's the formula I'm going to use. But then I come over here, and if it's doubling every 3 months, then I'm going to put a 3 where A is. Now, I don't know the initial amount of rabbits that were on this island because they've been on there for 8 months. So what I'm going to do is I'm going to use this information that's given to me to figure out the initial amount. So here's the equation that I'm dealing with right here. So I don't know the initial amount. This is constant. I know that after 8 months, how many rabbits have been on this island, and it doubles every 3 months. So we're going to solve. And the first thing that I need to do is just take 4,100 and divide by 2 to the 8/3. Now, if you want to type in 2 to the 8/3 first in your calculator, that's fine. I'm just going to use my calculator and be very careful and put parentheses around my fraction, hoping that I don't make a mistake. So I'm going to do that right now. I encourage you to do that as well. And I just got approximately 645.7. So that's 645 rabbits. Okay? That's our initial amount. So that's going to help me when it comes to part B, because I want to use this initial amount to make a prediction. So I'm going to use this initial amount to make a prediction for what happens after 1 year. So this was all part A. Part B, I've got my initial amount times 2 to the something over 3. Now, since it's a year, I'm going to put 12 for 12 months because 3 is in months. And all you have to do is type this in your calculator and go ahead and take a second to do that. You should get, oops, that's the answer from the last one, so I'm actually have to do this. So let's do this. So 645 times 2 to the 4th. So it gives me 10,320 rabbits. Okay, so make sure you can type that in your calculator and get the right answer. Here's the next formula that we're going to need, and make sure you write this down. You're going to want to use this formula anytime you see something about relative growth rate. So variables mean all the same thing. Initial amount, you've got your rate, time. So make sure you pause it, write all of this down. I'm going to show you an example when you're ready to move on. Alright, so this time we're talking about bacteria again. We have our initial amount is 500. At this point, you could probably go ahead and go through and try to do some of these on your own. So just pause it as you feel ready to start doing these on your own, and then play it when you're ready to hear me yap about the problem. Okay? So we've got the initial amount, and we've got the keyword relative, so that tells me, ooh, I'm going to use this NOERC formula, and our rate is 40%, so my initial amount is 500, and E is just E, the rate is 0.4, and T is your time. So there's your part A, writing your equation. And so parts B and C are using that equation. Part B, you're just going to plug in 10. And part C, you're going to set that equation equal to 80,000. So I'd really like it if you would try those on your own to solve. I'm going to go ahead and reveal the answers, so make sure you pause it before I do that so that you can try it on your own. But these are the answers that you should get. If you're not getting those, help each other out or ask questions when I come back. Okay, I'm actually going to skip over that and move on to half-life. So those of you that are in chemistry will either hate this or love it, so sorry. And now we're talking about elements and their half-life. So MO is our initial mass. How much of that element we're going to have. E is just E. We're going to have negative RT. R is represented by this equation here, so make sure you write that down. I'll always tell you the half-life. It's not like you have to memorize these or anything. So here's an example with that. We have this element, and we know that its half-life is 140 days, and its mass is 300 milligrams. So we're going to start with 300 milligrams. Got our formula is E to the negative RT. I'm going to find R by using that formula, ln2 over H. So if you want to go ahead and type that in the calculator, ln2 divided by 140, it's 0.00495 approximately. And if you could always leave it like this, but using a decimal might make it a little bit easier. So write that here, and then T. So that's going to be part A. That's just your equation. Part B, we want to know how much is remaining after 1 year. Now, since this is in days, I want 1 year to be represented in days. So when I plug in my T, I'm going to put 365. And so that's just going to be you typing some buttons on the calculator. And the last one, I'm going to set this equation to 200 grams. And you're going to solve and figure out how much time has to pass for that to happen. So again, pause, try these on your own, and when you're ready, play so you can see the answers. So these are the answers for that one. Okay, so this last one is Newton's law of cooling, and we're actually not going to worry about part B. We're just going to focus on setting up the equation. So your T sub S is the room temperature, and your D sub 0 is the initial temperature. Okay? So I want you to try and think about what that equation would look like. I'm ready to play so you can see the answer. There it is. Okay, I have one last example for you that is a compound interest example. And so we've already done this formula before. I'm just going to plug in everything where it goes. Your principal is what you start with. Your rate, make sure you move it into a decimal. Number of times per year, semi-annually, it's twice. And the time is unknown. We want to know how much time has to pass for the money to double, so 5,000 to 10,000. And this basically is going to be you solving and pushing buttons on the calculator. So divide both sides by 5,000. You can go ahead and type in this whole mess in the calculator. So 1 plus 0.05 divided by 2, 1.025, 2t equals 2. Take the log on both sides. So you're going to have log 2 divided by log 1.025. Divide that by 2, and I got approximately 14 years for my money to double. Not too bad, because if you did that now at the age